difference between. Today we are discussing the difference between some quantities. It means that today we will discuss about versus, that say is EMF versus PD, that is electromotive force versus potential difference. Network versus circuit, open circuit versus short circuit, sequential circuit versus combinational circuit, alternating current circuit versus direct current circuit. Let's start with the very first versus, that is EMF versus potential difference. EMF versus PD, that is electromotive force versus potential difference. EMF, electromotive force, is defined as the maximum potential difference between two electrodes in the cell. The condition towards that when no current flow through it. It means that circuit must be open circuit. Where is now coming to the potential difference? Potential difference is defined as the difference of potentials between 2 points or in any 2 points of a circuit. But circuit must be the closed circuit. Now, as far as concerned to the electromotive force is independent of resistance of the circuit, while potential difference is proportional to the resistance of the circuit in any 2 points of the circuit. So now coming to the third point, that electromotive force is generally known as a source of EMF which moves the electrons in a wire, while potential difference is defined as the potential or voltage which is defined towards the work or energy per charge, which may be the potential difference may be the potentials of electrodes in a cell in any 2 points of the circuit. Now coming to the fourth point, electromotive force is greater than the potential difference of the circuit, because EMF is the maximum potential difference. But while, or we can say that when the cell is being charged, in the process of charging, potential difference is greater than the EMF of the circuit. So electromotive force may be also defined as the maximum energy of the cell to be delivered, while potential difference is the difference of the potential between two terminals of the battery. It might be zero in ideal condition. Network versus circuit. A circuit is a network which has the closed path or closed loop in which current can flow easily, while a network is an interconnection of active and passive components, say is resistor, capacitors, etc. A circuit may only be a closed path, while a network may be closed or open path. A network may or may not have a function. In network, current can flow in the path where the network is closed, but when the network is open, current will not be flow through it. A circuit has a function, say it is done the function of electric motors, it may be done the function of we can say lamp, bulb, filament and all other devices which are used at industries as well as domestic appliances, while a network may or may not be a function. Say we can draw a network, so in the network there may be we can say the transmission lines, distribution lines, all other. Open circuit versus short circuit. An open circuit is a circuit in which the resistance of the circuit becomes infinity. It means no current flow through the circuit. Say is, according to Ohm's law, I is equal to V over R, which we have discussed in the video of Ohm's law. So resistance of the circuit is being infinity, so V over infinity, whenever the infinity comes in the denominator, as you can see from the equation, so current will be equals to 0, because whenever the infinity comes in the denominator, it gives the value equals to 0. Now coming towards the short circuit, a short circuit is a circuit in which infinity current passing through the circuit. It means that when we are taking the equation R is equal to V over I according to Ohm's law, so R is equal to V over, as you can see from the equation, I is equal to infinity, so infinity again come in the denominator, so the value will be equal to 0. It means in a short circuit, resistance of the circuit becomes 0, current of the circuit becomes infinity, while in the open circuit, current through the circuit is 0 and resistance of the circuit becomes infinity. The practical example of both the circuits are that in our home appliances we are getting the information that short circuit occurs. It means that excessive amount of current is over there. So we are using some devices which we use to protect from the short circuit, that are fuses, which you are going to see at your home, domestic places, that fuses are there, or many other terms to oppose the flow of short circuit. We usually use the reactor. So reactors are used over there. So this was the main difference of short circuit versus open circuit. Sequential circuit versus combinational circuit. Now combinational circuit is defined as the circuit which is independent of time, because it is not dependent on the clock signal. It does not need the previous inputs to get the output. It only needs the present input to generate the output, because it memorizes all the previous inputs. While sequential circuit is a time dependent circuit, it does not has a memory signal. The main difference between combinational and sequential circuit is that combinational circuit has the combinational part with memory signal. So sequential circuit is a time dependent circuit. It depends on the clock signal, which gives the previous signal, and to get the output it needs the previous, or we can say the past as well as present input to generate the output. Now by summarizing that, combinational circuit has memory, sequential circuit does not have memory. A combinational circuit does not depend on time or clock signal, and while sequential circuit does depend on the clock signal. Now we are coming to the examples of sequential as well as combinational circuit. The combinational circuit operate logically by Boolean algebra or truth table. So the examples of combinational circuits are half adders, full adders, multiplexers, demultiplexers, encoders, decoders, etc. Because in all that circuit memory is over here, and they do not need the past input to generate the present output. So now coming to the sequential circuit, the example of sequential circuit is we can say registers, clocks, counters, etc. And computers, it means that the circuit which are using in the computers are the combinational logic circuit as well as the sequential logic circuits. So we will draw the logic gates in the extended videos, and we will tell you in the digital electronic state how combinational circuits and sequential circuits apply. Alternating current circuit versus direct current circuit. Now coming towards the DC circuit, DC circuit is known to be direct current circuit, which allows the flow of current in only one direction. It means that current will only flow in the one direction, it will not flow periodically. And we can say that this type of current is given by the output of batteries, some rectifiers, DC devices. Now coming to the alternating current, that is AC circuits, in which current flows through the circuit periodically. Coming to the AC circuit, you can see the periodic cycle, which starts from 0, and once a half cycle comes at 180, then complete cycle will again be 0. Upper side of the wave is called crest, and the lower side of the wave is called trough. So means upper cycle is positive cycle and lower cycle is negative cycle. Now coming to the voltage of the DC, mean direct current circuit, it also flow across the direct current across the circuit, maybe direct voltage. We can say that a supply from the battery says plus minus 12 volt is shown from the circuit, while AC voltage also periodically move, or a cycle of AC voltage is same as the cycle of AC current, because it reverses the direction of the current. If we know that current is in a scalar quantity, it does not have a direction in that means, because it is a magnitude, but due to the cycle views, we can say that positive half cycle of a current, negative half cycle of a current, which generally knows the frequency of the current and voltages. Now coming to the second point, resistor or a lamp is used in only DC, while capacitors and inductors, coils, magnetic field, electric field, charging is moving, that all things are used in the AC circuits. So motors are also divided into two parts, DC part and the AC part. Machinery is also divided into DC and AC parts. So that's all about AC and DC.